You know, every now and then, an object from another star system pays us a visit. And sometimes it doesn't just challenge what we know, it completely rewrites the rulebook. Today, we're going to dive into the story of a really mysterious interstellar comet that did something, well, something that should be impossible. It hit the brakes. So this is the big question, the one that's been driving scientists crazy. As this comet was on its way out of our solar system, it started to slow down. But here's the thing. According to all the physics we know, it should have been doing the exact opposite. It's a total head-scratcher, and we're about to unpack why.
All right, so let's meet our protagonist. Its name is 3I/Atlas. Now, this isn't just your average chunk of ice and rock. This thing is a true interstellar traveler, a messenger from that vast, empty space between the stars. When 3I/ATLS first dropped into our cosmic neighborhood, it was absolutely screaming along at 26 kilometers per second. That's almost 60,000 miles per hour. I mean, that's a speed that makes perfect sense for something coming in from deep space. At first, everything was behaving exactly as it should. So far, so good, right? Well, that's where the normal story just stops. Because as astronomers kept their eyes on it, tracking it on its way back out, they noticed something really odd. Its speed was dropping. Not by a lot, but it was undeniable. It was decelerating. And that single observation sent a huge shockwave through the whole astronomical community. Why? Well, that gets us to the real heart of this mystery. The reason this is so mind-boggling is because it creates this massive conflict between what our laws of physics say should happen and what our telescopes were actually seeing, plain as day. Okay, let's break this down. As the comet is flying away from the sun, you've basically got two big forces in a tug-of-war. First, there's the sun's gravity, which is always pulling it back, acting like a brake. But at the same time, you have the solar wind, this constant stream of particles blasting out from the sun that should be acting like a tailwind, pushing it and making it go faster. But what we saw was the comet slowing down way more than gravity alone could ever explain. That means there has to be some other invisible braking force out there, something strong enough to beat the push from the solar wind. So scientists did what they always do. They started ruling out the usual suspects. Could it be outgassing, ice turning to gas and acting like a little rocket engine? Nope. They looked at its light signature and there was barely any gas. What about a gravitational pull from Jupiter or the other planets? Not even close. Way too weak. Well, could the instruments just be wrong? No way. The slowdown was too big to be just some random error. They had hit a total brick wall. And this is the point where a totally radical new idea enters the picture. One that says, hey, what if this isn't just a comet? What if it's something way, way more interesting? Say hello to the magneto-metallic attraction hypothesis, or MMA for short. The basic idea is that 3I/Atlas is not your average icy snowball. The theory says it's a massive 33 billion-ton object packed with metals like nickel. And over its incredibly long journey through space, it's essentially become a giant polarized magnet. So how does this solve the puzzle? Well, think of that cosmic tug-of-war again. You still have step 1, the solar wind pushing the comet away. And you still have step 2, gravity pulling it back. But the MMA theory adds a crucial third player to the game, an extra pull. The idea is that the comet's magnetic field is attracted to the sun's, just like two opposite magnets snapping together. And that creates a second, incredibly powerful brake. And that magnetic attraction? That is the mysterious force that astronomers were searching for. It's strong enough to completely overpower the push from the solar wind, and when you combine it with gravity's pull, it explains the slowdown perfectly. But believe it or not, the story was about to get even weirder. Just as scientists were trying to get their heads around the slowdown, 3I/Atlas decided to throw another curveball, and this one would turn out to be the most dramatic piece of evidence yet. As the comet got to its closest point to the sun, people watching noticed its usual green glow just vanished, and in its place was this brilliant, intense blue color. A color that was, and get this, spectrally bluer than the sun itself. So why is that such a problem? Well, in normal physics, for something to glow that particular shade of blue just from being hot, like a superheated piece of metal, it would need to be over 6,000 Kelvin. It would have to be literally hotter than the surface of our own sun, which is, completely impossible. And this is where that magnetic hypothesis comes back in a huge way. The theory says the glow isn't from heat at all. It's electrical. The comet isn't a glowing piece of hot coal, it's more like a giant fluorescent light bulb being plugged into the sun's power outlet. It's glowing like an aurora from electromagnetic excitement, not from being super hot. Suddenly, the color change makes perfect sense. It's like a dimmer switch. When the comet is far away, the sun's energy field gives the particles a little jolt. The dimmer's on low, and they glow green. But as it gets super close, the intense solar energy gives those same particles a massive jolt, cranking that dimmer switch all the way up, and they release a much higher energy, brilliant blue light.
So you see, that impossible blue glow wasn't some new mystery. For the scientists who proposed the MMA hypothesis, it was the final confirming piece of the whole puzzle. It was the smoking gun.
I love how the theory's author, Alexander Campaign, put it. He said, "The change from green to blue is not a contradiction. It is the climax." I mean, that just says it all, doesn't it? It's the moment everything clicks into place. And that's the real test of any great scientific theory. The MMA idea didn't just explain the slowdown after it had already happened. The principles of the theory actually predicted that as the comet got closer to the sun, its glow would intensify and shift to a higher energy blue. Right now, it's the only model out there that explains everything we saw.
So that leaves us with one last really fascinating question. Was 3I 8-less just a complete fluke, a one in a trillion magnetic marvel that we happened to see? Or is this strange visitor a hint that the universe is far more electromagnetic and a whole lot stranger than we ever imagined?